Okay, so one more time. So on this one, let me just make sure this one was clear. So we clear with how to solve that one. Does that make sense what I did there? I just took the two equations, x plus y is 8 and x minus y is 2, and I added them vertically. Got 2x, the y's canceled, plus y and minus y is 0. 1x and 1x made 2x. Then I divided by 2, x came out 5. Then come up here, plug in the 5 for x, right here, plug in 5. Solve for y is 3. Now on this one's a little different. What would you do, you think, with this one? What can you do with that first equation?
Divide 2 over x.
Boom. Yeah. Right? Just take that first one. 2x is 12 divided by 2. X is 6. And then just plug that into the second one and away you go. All right? I'll move on. Just these? 11.1. One test on 11.1. Huh? It would make me look better. I always get these notes. We all get these notes, about our pass rates. Administration sends us, and they'll show all your classes for the last 5 years or whatever, and they code in red or yellow, I don't know, highlight it, any ones where the pass rate was below. What did the school just say they want now? I think they said they want 71% pass rate or something. I think they just upped it recently. Anyway, anyone that's below that, my whole sheet's yellow. I just look at it, and I joke with my other math colleagues, how's your sheet? Yellow? Yeah, my whole sheet's yellow. I mean, I'm doing all I can. I mean, I don't know what else to do, but the administration's not happy with me or any other math teacher. All of our, and they just say, we'd like pass rates to now be, they just about a year ago, they said 70, and I think, what, you just picking a number? I'd like them to be 100%. But, I mean, we can't just force that. I mean, unless we want to just lower standards, and then the universities won't accept our classes. I mean, what do you want to do? Anyway, I won't get into all the politics of schools, but my pass rates are never where they're supposed to be. So, all right, what do we do on these? What do we do? Can you look? Can we do the addition method thing here? 2x plus y is 9. 10x plus 5y is 14. Yeah, if we added them right now, it wouldn't work. We got to do the -5 things. Everybody see that? Remember these from your algebra days? If I was to add these right now, don't do this. It won't work. You'd get what? 12x. This is 1y, 6y, 5y, 6y. That's something like 23. It didn't work. What do I mean it didn't work? What didn't work? Nothing canceled. I need one of those letters to eliminate. That's why it's called elimination, huh? You need one of the letters to cancel out. You can't really deal with two letters at the same time. We need to get down to just one letter. So that didn't work. So you have to tinker with them. You got to fiddle with them before you add them to make somebody opposites. You see how the last one, this one right here, see how these y's already were opposites? +1, -1. So I didn't need to fiddle with them. They just automatically were set up nicely and dropped out on their own, made 0 on their own, right? Whereas this one, I need to do something. So what do you do? I can do the y. How about the x's? What can I do to make those two x's? You got to make them the same number, but one positive, one negative, the same number, so that when you add it, it's 0, and it eliminates, right? So what do I got to make that top x? Or what do I got to do? I got to multiply by -5, huh? Does everybody see that? See how that'll work perfectly? Because that'll make this right here -10x, and it'll cancel with the positive 10x when I add them in a minute. So you got to make them opposites, huh? You got to make the two x's or the two y's opposites, and in this case, surprisingly, they're going to both be opposites. Unintended result. We'll see what. That's why I wanted to show you this one. This one's going to have a weird result. Now when I add them, I purposely made the x's opposites. No surprise, they cancel out 0. But look what unintended result happened. The y's also canceled, and this is some number over here, 31, or -31. See what happened? That's weird. X and y both dropped out. I didn't mean for that to happen, but it did. So what does that mean about the answer to this problem?
There are
no solution, yeah. Let me show you the rule. So when x and y both cancel. So when both x and y cancel at the same time, that's what happened here, right? 0, 0. There's two things it can mean. If you get something like 0 plus 0 equals negative 31, that's no solution. That's the first thing. But if you get something like 0 plus 0 equals 0, or 0 plus 1 equals 1, something that's true, that's infinite solutions. Those are the two weird cases. Does everybody see that difference? So when both x and y cancel, you can get something that's not true, and that's no solution. It's a no-no. You remember it that way. Right? If it's not true, 0 plus 0 does not equal negative 0. That's not true, no solution. But 0 plus 0 does equal 0, or 0 plus 1 equals, if you get something that is true, that's infinite. When there's no more letters, just numbers. So if all the letters drop out, x and y vanish, and all you got is numbers, you know it's either going to be no solution or infinite. How do you know which one? Is it true? Are the numbers left over true or not true? If they're not true, no solution. If they are true, infinite solutions. Question?
So then for no solution, they don't have to be 0, do they?
They don't have to be 0. But the x and the y have to vanish.
Right.
So the x and the y have to be 0. Yeah, so I guess it will always be 0, 0, 0. Yeah, for infinite. Yeah, because they have to be 0. Yeah, x and y have to be 0. Yeah. Make sense on that? What does that mean behind the scenes? You remember from your algebra days, these are two lines, aren't they? Right, these are both first power. No x squareds or y squared, no curvature there. Those are both straight lines. What are the three different things two straight lines can do? Two straight lines can intersect in one point. That's when you get one normal answer. Two straight lines can be parallel, not intersecting. That's no solution. They don't touch at all. Or two straight lines can be right on top of each other. Infinite intersections. That's the third case. Now, we're not graphing, and we don't want to graph. But that's what's happening behind the scenes. That's what's really going on. Why we're getting three possible things to happen. No solution, infinite, or just one normal answer where they intersect. Well, this is the infinity symbol, but they don't usually write that for, not usually written that way. Yeah, it's just no solution or infinite solutions on that, yeah. How do we solve a big, ugly 3 by 3 equations, 3 letters? Look at that. How are we going to solve it? You can solve it by hand. It's tedious. I'm just going to tell you to hit the buttons on your calculator. So this will be on the graphing calculator part of the exam. Bless you. You'll notice, by the way, practice exam number 3. Heads up, small change. I don't know if you've looked at it already. Practice exam number 3 and real exam number 3. Part 1, have I already said it? No calculator at all. Part 2 is graphing like normal. So part 1 is no calculator at all. No calculator at all. Now, I'm not going to make you do terrible numbers in your head. It won't be like that. They'll be reasonable numbers. I'm not going to make you do the square root of 481 or something crazy like that. It'll be simple add, subtract, multiply numbers. But I do want to make sure you can actually solve those things. There's things that you should be able to do without a calculator at all on that. So heads up. I don't want to surprise you. I aim to not surprise you. It says it right at the top. And so I want to let you know, no calculator. Also make sure, part 1, 8 questions. It's mainly hyperbolas, parabolas, ellipses. That's what part 1 is. You'll see it when you look at it. It's all those graphs, so no calculator at all. Just, right, you can do all those numbers without a calculator. And then part 2 is graphing. So anyway, this stuff will definitely be on the graphing part. I'm just going to say hit the buttons here. I don't want to solve a 3 by 3 by hand. It's painful. You can do it if you want to. Let me show you how to use your calculator. You guys have your graphing calculator? We got to make this into a matrix first off. So here we go. I'm going to peel off the numbers in front of x, y, and z. There's a 1 here, a -1 here, and a 0 there. 1, -1, 0. See what I'm doing? I'm just grabbing the numbers in front of x, y, and z. And if a letter's missing, like z is completely missing, that's 0. Good so far? And then this is 5, not 1, whoops, there's no y there at all. 5, 0, minus 7. 5, 0, minus 7, and this is 0, 5, and this is 1. Everybody tracking with what I'm doing? I'm just peeling the numbers off of XYZ, XYZ, XYZ. Now, what about the numbers on the right? Yeah, just stick them in also. 2, 20, 10. We good to there so far? All right, so if you got a calculator, a TI kind of calculator, then here's what you do. You have to put that in. So you got to hit on the TI, got to hit second matrix, which is on the left side. Maybe I'll show this on the overhead too. It's on the left side. It's the fourth, it's the x to the minus 1 power. See the x to the minus 1 power key? So find that one. And then so hit second matrix. And then your screen will open up and allow you to enter. Then go over twice, 2 arrows twice, and, to the edit screen and hit enter. Go over to edit twice, hit enter. And then it'll say matrix A. And you need to type in the size of the matrix. What's the size of this matrix? Matrix is down and then across. This is down 3 rows, across 4 rows. It's a 3 by 4 matrix. So you got to hit 3, enter, 4, enter. It'll set up a 3 by 4 array for you. I'll put this on there after I've written it out. Then you type the entries. When you're done, hit second quit, which is above the mode key, right on the top. Then you've got it. It's kind of like using a word processor or something. We're entering the matrix. It saves it, and then we just quit out of there. And it's got it in its memory bank. Does that make sense what we're doing? It's like we're entering a document and saving it on the graphic calculator. We're entering a matrix. Once you've got it entered, every time you hit enter, it's saving that number in that spot. Hit the last one, enter, and then just quit. It's got it. It's got it in there. And so then you come on out of there, and you hit something else. Second, oops, let me change my plan here. Hit second matrix. And then just hit, then go over once to the math menu and go down to the RREF menu. RREF. And hit enter. And let me write this a little more clearly. Go over to the math. Go down to the RREF and then hit enter. I'm going to do this with you. And then hit one more time. Second matrix. Again, we keep going in and out of the matrix menu. And then just hit enter. And hit enter one more time. And you get an answer. What you'll get on your screen is 100010001 420. This is your X. This is your Y. This is your Z. And you're done. There it is. Y'all getting that to happen? Yep and nope? Nope and yep? All right, want me to show something? So you guys all got that copy down? I'll show. Oh, I had to switch screens though. It'd be nice if I could do one screen for each thing, wouldn't it? I had like a... What's that?
I have a Casio.
Yeah.
Did you go to Matt? Which one you got?
I got to the matrix, but I have no idea how to solve it.
I don't know either.
Yeah, I have
Can you find an RREF thing?
I have no.
I can help you probably after class. Go on YouTube. I mean, it might take 5 minutes.
This is on YouTube, correct?
Oh, yeah. Yeah, go on YouTube. Yeah. This will be, this is on YouTube. But yeah, if you have a Casio, just go on. Literally, it would be this easy.
You type in your calculator, like.
You would just go.
You can do a tutorial on how to solve, and it'll show you, it'll be like maybe 5 minutes.
All right.
Go YouTube, Casio. What's your Casio? FX.
9860.
FX 9860?
Yeah.
Matrix. Matrix. Solving. Well, RREF. RREF and Casio FX. And it's a different one, but it's going to probably be the same thing. Click on any of these, they'll show it. I live by YouTube. It's very helpful. Need to do something yesterday on Excel I didn't know how to do with copy things. I just YouTube, Excel, boom, there it was. All right, so yeah, just do that. They'll show you how to do that. Is everybody that has a TI getting the hang of the...
Do you know how to get from this part? I got there, but it's already got like a 3x4 in the math part, and I can't get to the...
Okay. Yeah, I've only got 5 left. I could... let me see, what could I do? Where's the button? Oh, it's this one. It's not labeled. That's why it's confusing me. So yeah, let me show here real quick. So here's the steps I was talking about. So you would go second matrix, go over to edit, hit enter, and then you got to go 3x4, enter. I'm hitting enter every time. 3, enter, 4, enter. And then enter then here I just typed them one at a time. Every number, enter, enter. And make sure you do negative. When you do the negatives, don't use the subtraction button. Remember, the calculator gets all bent out of shape. Use the negative. It's really picky. I don't know, I think the Casio's fine with it, but the TIs get all upset. And when you got the whole thing entered, hit second quit. Here's the quit right up here. See it? Right at the top. Go. So once you've got it all entered correctly, go second quit. And then go back into second matrix again. Go over to, just once to the math menu. And then go down the math menu to RREF. Stands for Reduced Row Echelon Form. Hit enter. It puts it on the main screen. Then you go one more time, third time into second matrix. And there it is. It's on A. What this is, you're calling forth matrix A. You're saying, I want to do the RREF thing on matrix A. So you're saying, yeah, matrix A, that's the one. See, it's on matrix A right now. You're naming matrix A. It's like a magic spell. You're calling it forth into the main screen. Boom. There it is. A is on the main screen. You don't even need a closing parenthesis. Just hit enter again. There it is. So those numbers on the right, 420, that's X, Y, and Z. Yep, always in that order. Yep. There it is. So that's how you handle all the 3x3s. 3 minutes. Let me see what we can. All right. Can we set up number 12? 82 commercial, non-commercial orbital launches worldwide. Number of non-commercial orbital was 2 more than 3 times number of commercial. Basically, it's 2 letters, 2 equations. You see what they're saying? You've got commercial, non-commercial. Total 82. What do you do with that? They total 82? The number of commercial launches and non-commercial is 82. In addition, non-commercial was, that's past tense of is, that's like in is, in was equal to, right? 2 more, 2 added, then 3 times commercial. 3 times commercial. There it is. n equals 2 plus 3c. Does that make sense how I handle those words? So now I've got two equations with two letters. Yeah?
So then wouldn't you want to get the C to the other side with N?
You could do that. I think this one would be, yeah, if we wanted to do the elimination method, that would totally be what we would do. This one is set up nice just to grab this and pop it in right there. I think that'd be easier. This one's better for the plug-in called the substitution method. But you could do the elimination method if you want to. You know, move it over and line them up and all that. But this one will be nicer. I think it's kind of set up, ready to go for the plug-in method, the substitution. Why? Because one of the letters is alone. When they've already given you one of the letters as alone, it's nice to just plug into the other equation. So, so this would be C plus, here's what I mean. So the N would become this, right? Because N is 2 plus 3C. So like that. You see how I'm doing that? See how this replaced N? Because N is that. N is 2 plus 3C. And now we can just do like, now it's only one letter. It's just C. So we can do like terms, 1C and 3C, 4C. See how easy that is? Subtract 2, 4C is 80, divide by 4, C is 20. Got C, you can plug in and get the other one, and it would be a happy day. It's all good. All right. You guys had enough math for the day? We got to do the clicker.
Clicker the ticket.
All right, the airwaves are open. Click A for Apple. It's a free click. You guys click fast. It went from 0 to 10 like that. All right, click A. We're done. So, oh, we didn't finish 11.1. All right, we didn't finish 11.1. So just 10-4 in the practice exam. We did not finish 11.1. 10-4 in the practice exam for Tuesday. Work hard in that practice exam. Get some help. Have a good weekend. Don't pay any attention to your other classes. Just whatever. I'm just kidding.
I have to.
Oh, you got poli sci too?
Yeah.
Yeah.
Something everyone has to take.
Yeah, no, it's required for everybody. Who do you have? Mr. Mark? Vu. I don't know that one. Okay.
You know what you do in poli sci?
Yeah, I get
The one thing about history is it's time to change this.
That's right. History keeps repeating. And
I know.